Okay, this is video 2 for the PK MACH series boiler with the ENVI controller. And what you're seeing here is the full page wiring diagram. When you click on this, you're going to see this full page wiring diagram here. You can rotate it so that you can look at the whole thing, but it's kind of small and hard to read. But while we're looking at this, this is the ENVI controller right here, what they call the ENVI control board. Over here is the communications board. Here is the display. Yeah, you can see the display is just two wires. And then when we looked at the exploded view of the boiler, here is the high voltage terminal board and the low voltage terminal board, terminal block. So for reference information, that's what you see. Here's the low water cutoff. I want to show a little more detail about that on a terminology page. But let's go back to the main menu here and look at the expanded wiring diagram. So there is the diagram we were just looking at, and then I expanded it here. Hopefully this helps see a little bit better what all we got here. So let's start on the far left here. I'm going to make this just a little bit smaller. Here's the ignition electrode, and you can see it says igniter, terminal 2, T2, and then ground, igniter ground is J12. And it actually is to a physical ground. So that's the ignition electrode, and you get an arc right there. That's what lights the gas. Next thing here is PWM output, and I hope you remember what PWM stands for, because I'll put that on the quiz. It's pulse width modulation, and because this is an output, we know that that's a signal going to the blower motor. Much like both the triple flex boiler and the Clearfire boiler, it has a pulse width modulating output signal that signals the blower to run at a specific speed. And here we've got an input signal and a ground. So the blower motor gets a signal from the control board to speed up or slow down. It gets a feedback signal from the blower to the control board so that it knows for sure that it actually did achieve the right speed, and it knows that the blower is going the right speed. Over here, your terminals 1, 2, 3. Here's your L, N, and G, 120 volt, neutral, and ground. You'll see here that this one has a high limit thermostat. If you remember, on the Clearfire boiler and on the triple flex boiler, they did not have a separate high limit control. They actually used a dual element thermistor that sufficed as a high limit control, but this one does not. It has its own a separate high limit control, which you would have to locate this in the boiler, and if you went to the IOM and looked at the expanded or the exploded view, you would be able to find where this high limit is physically located. You'd want to be able to test that. Here are the terminals for the gas valve. There's two terminals here that are gas valve valve H, gas valve N, hot and neutral. And you can see that these two gas valves are wired in parallel to each other. And I might put that on the quiz because it's important they are wired in parallel. The same wire from hot that goes to this gas valve is L, goes up to this gas valve is L. Ionization, I think we talked about this on the Clearfire boiler. Ionization is a way of measuring whether or not flame is present, and it's done with what typically is called a flame rod. A flame rod can read the current or a voltage or current flowing through the flame to a grounded surface, and that's how a flame rod works. So this is the flame rod terminal here, J13-2, and then there was the gas valve ground. Here is the central heat, or I guess they call this one the comfort heat pump. So when you see this, it comes off a J74 right here, but then it goes to TB213, And TB213 is way down here in the corner. It's the actual terminal block 2. I think terminal block 2 is the high voltage terminal. And you can see that here's the domestic hot water pump if you're using that. If you're using a 3-way valve, there's the terminal for it. Here is the 120 volt power coming in, and you'll see right here where it shows the 120 volt power coming in. There's TB3-1 is 120 volt H. That is this terminal right here. So that's the high voltage terminal block. And you can see here that on the TB3 terminal block, or your power input terminal block, it actually feeds out to J23, which is right here. It feeds out to F13, and it goes to low water L1 or LWL1. As we scroll down, here you see LWL1 right here. That's 120 volt going to the low water cutoff. And I'm fairly certain that the F1, here it is right here, F1-3, that's power for the communications board. So now that we're looking at the bottom half of this, this is the, let me get back and give you some reference here. This is the actual ENVI controller and its terminal strips from J9, J13, J7, J6, J4, and J2. And then on the bottom half here is the connections here. The first one is HGPS. And I'll probably put that on the quiz because those initials are important to know that that is the high gas pressure switch. And now that I look at it, this boiler does not have a high gas pressure switch. If it did, it would be tied in right there. It does have a blocked flue. If you look at this, here is the blocked flue switch, and the wire coming off the blocked flue switch goes through an interlock. And I'll talk about that. You know, the interlock here is a jumper that's on the low voltage terminal strip and comes across here to the blocked flue terminal. So, you know, if you had an alarm for blocked flue, it would mean that this normally closed pressure switch, and is shown as a normally closed pressure to open pressure switch, means that there's too much combustion chamber pressure. Typically, if there's too much combustion chamber pressure, that means the flue is blocked. So, blocked flue switch. And here is the airflow switch. You can see it's normally open, and as the air pressure increases, it closes there. It goes into the air pressure switch, and then here is LGPS, low gas pressure switch. So the terminal here, HGPS, is for high gas pressure, but it is not used. It is there is no high gas pressure switch. Down here is the low water cutoff, and again, I'm going to put this on a terminology page. I'll probably pause the video here in a minute and do that. The low water probe, and you'll see this push to test the low water cutoff. And actually, when you look at this, all you're doing with a momentary push button switch, a momentary normally closed push button switch, is when you push the button, you're opening the contacts across these 2 points here, which is simulating that the probe is missing or the probe is not touching anything like water. And if there's no reference from water, the probe in water to ground, then the low water cutoff would say there's a problem. It would open this contact, and you would get a low, let me find it here. Block flue. Well, I guess there's not a terminal necessarily called low water cutoff, but it should be. I think there might be an error in their designation for this. But anyway, that's how it would shut off on low water if this switch here open. Of course, the low water cutoff has power to it all the time. Here's a stack temperature switch. It says flue gas NTC. I know it's kind of blurry, but I can read it. Hopefully you can. Flue gas NTC. Everybody knows what NTC stands for, or you will have to remember that because I'm going to ask that on the quiz. But there's the flue gas thermistor, It is an NTC. Here's the return water thermistor and supply water thermistor. All three are NTC. And I do want to look at the ENVI manual. There's a couple ENVI manuals, different versions, but it actually gives the temperature resistance chart for these three thermistors. And it's a little bit different than the 10K. It's actually a 12K. And why does a manufacturer use a 12K instead of a 10K? Well, they want you to buy parts from them. And maybe they're the only ones that sell that. I don't know. But if you had a domestic water heater that you were heating with this heating hot water boiler or comfort boiler, you could hook the domestic hot water sensor in right here. And then here is the control link. That is your communications. And here is your 24 volt stat input, enable versus disable, just like on the XXX and the Clearfire boiler. You have a stat input that is at 24 volts. Here on the board is the fuse. If something was to go wrong, hopefully it would blow the fuse and not ruin the board. Okay, I added another menu item here. It's called PK terminology, PK MACH terminology. And here's the low water cutoff that they use on this particular type of boiler. It's a Warwick Series 26 low water cutoff. And the fact that it says standoff here means that when you see these, they have little plastic standoffs that come up through these holes, and that's what holds it to the backplate in the control panel. This is what it looks like. It has a normally open, normally closed Form C contact. I should explain that sometime. Here's the standoffs. It has a contact rating of 10 amps. It has a sensitivity of 0 to 100,000, 100K ohms. That is the conductivity of the water. Here is some information about how the serial number is, and here's kind of the wiring. L1, L2, that's your 120 volt power. LLCO, that's your actual probe. And here's your ground reference. A lot of times the ground reference is just connected to the casing of the boiler. And here is your switching, your normally open or normally closed contacts. And here's your reset button. The reset button on these is actually a normally closed switch. And it has a little transformer built into it. Fairly simple low water cutoff. It takes 120 volts, and then you check for conductivity between the or through the water. Getting back to the diagram, let's look at this one first. Here is a place to tie in a header sensor. Here's a place to tie in an analog input. If you had a building automation system that you wanted to use to interface and you wanted to have a variable set point or something, there's your analog input. Domestic hot water flow switch if you had a domestic hot water system. Modbus communications is there. Anytime the boiler goes into alarm, you would have an alarm output here. And I want to go over these different terminals and stuff in the IOM because I can guarantee you that the alarm relay here and the boiler run relay here are what are called dry contacts. There is no power going to those terminals. It is just a way of seeing whether the contacts are open and closed. And I think it spells that out. Here is the air damper. If you have combustion air damper that you need to control, that's where it ties in. And then of course at the bottom of the page is the high voltage and low voltage terminal, and you're enable disable. So I want to go over some of this, but in the IOM it goes into very specifics about these terminals and what they're designed for. That'll be the third video.